Think about your last drive. Maybe your touchscreen froze while you were trying to change the temperature. Maybe your backup camera took 3 seconds to load. Maybe your dashboard flashed a warning message you did not understand, but the car still drove fine. Or maybe you discovered a heated seat or performance mode locked behind a monthly subscription, even though the physical hardware is already installed in your vehicle. None of this feels mechanical. None of this feels like owning a machine. You did not buy a smartphone on wheels. You bought a car. And yet modern vehicles now behave more like rolling operating systems than mechanical tools. Here is the strange part. Today's cars contain more software code than commercial airplanes, and in some cases more than military aircraft. And almost nobody remembers agreeing to this transformation. So the real question is not whether cars are becoming smarter. The real question is whether they are becoming harder for humans to actually control.
For most of automotive history, driving meant physical connection. When you pressed the gas pedal, a cable opened a throttle plate. When you turned the steering wheel, gears physically rotated the front wheels. When you hit the brakes, hydraulic pressure directly squeezed the brake pads. You could feel resistance. You could sense feedback. You could tell when something was wrong. That world is disappearing. Today, your accelerator pedal is often just a sensor. Your steering input is filtered by electric power assistance algorithms. Your braking force is managed by software coordinating stability systems, traction control, and collision avoidance. When you press the pedal down, you are not commanding fuel. You are requesting permission from a computer. This is the core trade-off. Mechanical control gave drivers simplicity, predictability, and direct authority. Software systems give manufacturers efficiency, optimization, and centralized control at scale. One model is built around human input. The other is built around system performance targets. And over the last 20 years, optimization has been winning.
A modern car does not have one computer. It has dozens. Engine control modules, transmission controllers, body control modules, battery management systems, infotainment processors, driver assistance controllers, climate systems, sensor fusion units, each running separate software stacks and communicating constantly. Industry estimates place modern vehicles between 100 million and 300 million lines of code, depending on complexity and class. For perspective, commercial aircraft operate with far less software complexity. Fighter jets, which manage weapons, navigation, and flight stability simultaneously, still contain only a fraction of what premium consumer vehicles now carry. This complexity did not appear overnight. It accumulated quietly. Early cars used mechanical governors and vacuum systems. Then came basic engine computers, then stability systems, then infotainment, then advanced driver assistance, then connectivity platforms. Old vehicles relied on physical components doing multiple jobs at once. New vehicles break tasks into specialized software-controlled modules. Cars did not become software because engineers were bored. They became software because modern standards made mechanical simplicity impossible. Modern emissions regulations require extreme precision. Fuel delivery must adjust in milliseconds. Combustion timing must respond to temperature changes. Exhaust sensors must measure output continuously. Compliance now depends on real-time feedback loops. Mechanical systems simply cannot do this accurately across different environments, driving styles, and fuel qualities. Safety regulations add another layer. Stability control mandates require constant monitoring of wheel speeds, steering angles, yaw rates, and vehicle orientation. Automatic emergency braking systems require cameras, radar, LiDAR, and complex decision software. Even throttle pedals move to drive-by-wire because computers must coordinate power delivery with traction control and crash avoidance. In other words, software is no longer optional. It is regulatory infrastructure. The trade-off is simple. Cleaner fleets and safer roads require digital control, but digital control reduces mechanical autonomy.
Here is where daily experience starts to feel confusing. Modern cars are more reliable in many mechanical ways. Engines last longer, transmissions shift smoother, breakdowns are statistically less frequent. But when things go wrong now, they fail differently. A worn bearing makes noise. A bad sensor can shut down your powertrain. A glitchy update can disable features overnight. A software fault can place your vehicle into limp mode even when nothing is physically broken. Mechanical failures usually give warning signs. Software failures often do not. This creates a strange psychological effect. You trust the hardware, but you fear the system. And that is why many drivers today feel less confident repairing, diagnosing, or even understanding their own vehicles.
Manufacturers did not resist this shift. They embraced it. Software allows automakers to reuse digital platforms across dozens of models. It enables remote updates instead of physical recalls. It reduces hardware redesign costs. It supports feature activation after purchase, and it enables subscription-based revenue streams. From a business perspective, cars are no longer finished products. They are platforms. Instead of selling a static object, manufacturers sell ongoing access to functionality, updates, and digital ecosystems. This changes the ownership relationship. You still hold the keys, but the company often holds the control layer. You gain convenience. You lose permanence.
To be fair, drivers gained real benefits. Fuel efficiency improved dramatically, stability systems reduced accident severity, battery management software made electric vehicles possible, navigation systems reduced travel friction, predictive maintenance lowered surprise repair costs. Software solved problems mechanical engineering could not solve alone. This is not a conspiracy story. It is a trade-off story. The problem is not that software exists. The problem is what disappeared as software took over.
As vehicles became software platforms, drivers lost transparency. You can no longer see how your car actually operates. DIY repairs became harder. Diagnostics became locked behind proprietary tools. Longevity became uncertain as vehicles became dependent on digital support systems and manufacturer servers. Even driving feel changed. Steering feedback is filtered. Throttle response is tuned for efficiency targets. Braking behavior is managed by stability logic. You are still driving. You are no longer fully in command. This connects directly to everything trade-off theory covers. Repair restrictions, safety weight spirals, locked features, subscription creep, they all come from the same root: system optimization replacing human simplicity.
We did not accidentally turn cars into computers. We chose efficiency over direct control. We chose system performance over mechanical transparency. And that choice reshaped transportation. So the real question is not technical anymore. It is philosophical. Are we building machines that serve humans or systems that humans are forced to adapt to? Because optimization keeps winning and control keeps slipping.